bell work today. You were supposed to explain why there's a bulge in the hydrogen peroxide bottle. So, but what's causing this? Let's see what your ideas were. Ions bouncing off each other create pressure. And I would agree that pressure is caused from things bouncing off one another. And on a particulates level, it could be ions, it could be molecules, right? So I get that. But what ions? Or what molecules? If it's not ions, then fine. But what molecules are doing it? It's also stored in a dark bottle instead of a clear bottle. What's it keeping out of it? Okay. Light is energy. And when energy gets to these molecules, it can also break it down. Our mission today is to use what we learned yesterday as far as lab procedure goes, and to analyze this as far as, is it really 3% hydrogen peroxide? Before we start the titration, and I go around and kind of ask you questions about it, we need to figure out what it is that's getting reduced and oxidized now that we switched out of the standardization with the ferrous ammonium sulfate, and now we're doing the hydrogen peroxide. So have that quick discussion. Go. What's getting oxidized? Would that be getting more positive? Yeah. So you don't always go for, like the iron one, from 2 to 3, right? But in this case, we're going from Okay, eyes here. We just had a quick discussion over here, and then I got kind of canceled. But go ahead, can you share with what we said? You can even go up to the board, one of you two, and kind of point it out if you don't mind.
The oxygen on this side, the oxygen is a -1 charge, and then when it switches over to this side, since it's by itself, it has no charge, which means it's at 0. And since it from -1 to 0, that's a +1, so it turns more positive, making it -1. That's oxidized.
Perfect. That's why. Anything in its elemental free state, which is O2, has a 0 charge, which we just learned that, right? So that's good. Okay. So let's go back to the slide. How many of you were thinking that it was oxygen? That was it. Thumbs up. Okay. What is it telling you now? And you only lost a couple drops. Okay, so you want more? Yeah. Always record when something like that happens. Just record it. Keep running the trial because you're only off by a little bit. And then with that, though, let me ask you this. Is that going to make your estimate higher?
Yes, I did that several times yesterday at work.
Why? It's hard to
Is it going to make it or is it higher because there's slow, it's going to be more in there?
more than what you're expecting.
Yeah, because it missed the whatever amount of calcium.
Know about the permanganate. So when I say go, tell your lab partner, what else do you know? Go. About the permanganate. The concentration.
So we know the concentration of the magnet.
Okay, so now we're getting somewhere. So when I add a set volume and a titration, that's my known. Right? So if I'm going to do any type of calculation to figure out something about what I put in my analyte, I always tend to start with my known, the titrant. For every 2 moles of permanganate, we use 5 moles of peroxide. That could use proof helpful, right? Because that first 0 is just placement.
Yep. So it's 166.
We started the yeah.
Okay.
And then we transitioned it down to the grams.
Where'd you get grams from?
The grams. I did the calculation there.
Oh, you did molar mass?
Well, you're gonna bring down the
Okay.
whole.
But now you're in volume, right?
Oh.
So, You got a conversion that deals with volume and moles?
Oh yeah, we got converted. This is in milliliters.
Are you pulling?
So we gotta convert that to liters first, and then
No, it's in milliliters. You have to go.
And then you're gonna bring it down.
mole to liter ratio.
And then the 1 mole, and then you're gonna bring down the mole, and you have the 5:2 mole ratio, and then you're gonna bring down the mole, change it to grain.
We want the actual weight, so we'll do the weight of the peroxide molecules over the weight of the actual solution that we tested. So did we test 100 grams of peroxide?
No.
How much should we test?
Oh, only one. So you put the grams that you get over one times 100.
Yeah.
Gotcha. So once we get to the, yeah.
Then what's it supposed to be?
3. We did pretty good.
Yeah. Lower than it should be.
You're gonna miss a few drops, that's what ours did for the milliliters of magnate.
Okay, so you went to turn yours on.
And it missed a few counts because it was too close to the liter thing.
Perfect. How does that change the outcome on this side? Go. Have that. So let's think mathematics now. I'm just going to throw this at you. If this is lower than expected and I'm multiplying, not dividing. So I'm multiplying with a smaller number, I'm dividing by the same number, my outcome should be smaller. If in the end I used the wrong number in the denominator and it was smaller, would that make my answer bigger or smaller? Bigger on that. Right. So part of error analysis is to know something happened during the lab, like you missed a few drops, but then be able to explain that into your conclusion as to why that happened.
Okay.
With numbers.